Hello everyone. Today we're going to be looking at the second integration method that many calculus students learn, which is going to be the biparts method. And I know a lot of people uh, that use this thing called the DI method or the tabular method, and you have a derivative and then you have your integrals and then you multiply with alternating signs. Um, I don't think that's the best way to do this. I think it actually has no meaning because Um, it's not a mathematical expression, but it does do the job correctly, but it does not show complete work, I believe. And so the way that the book teaches you how to do it is, let's say you have a function f times g, and then you find the derivative of it. This is going to be f prime times g plus, and then we have f times g prime. Okay, so this is just simple product rule. And then obviously you are going to see that um if we subtract f g prime from one side, we're gonna get this. Okay? And then from here, if we integrate the left side, or actually if we integrate the right side, we'll get the integral of f prime g, and it's equal to the integral of fg prime minus fg prime. And as we know from the fundamental theorem of calculus, this middle term, which is integral of fg quantity prime, that's going to be fg. And then we're just going to have the integral of fg prime. And so this is where the biparts method comes in. It shows us that if we have a derivative multiplied by another function, we can use this equation to solve the integral. So let's jump into a couple of examples. So if we have the integral of x times e to the x dx, the best way to do this is thinking what in our integrand is a derivative of something or is an integral of something. And so in this case, we know the integral of e to the x. We also know the integral of x, but e to the x is even easier because the integral of e to the x will be e to the x. All right, so just let's say note integral of e to the x dx is going to be equal to e to the x plus c technically. So take a look at this red part. What we're gonna do, we're gonna rewrite this, is we're gonna do e to the x prime times x dx. And then now what we do is we use our equation from earlier, which is e to the x times x minus the integral of e to the x. And now the prime jumps over to the next term, the other term. So what is x prime? It's going to be 1. The derivative of x is going to be 1 dx. And then now we can easily do this, right? Times x minus e to the x plus c. Alright, that's our answer. That looks terrible. Oh my goodness. Okay, let's just jump into another example. So if we have the integral going from 0 to pi over 2, and then we have, let's say, cosine x multiplied by 2x dx. So what we want to do right now is we want to say, what in our integrand do we know the integral of it? Or let me rephrase that. Something's derivative is equal to something in our integrand, right? So we're writing this. I'm gonna write it in blue. something derivative is present in our integrand. Alright. And so the best way to see this is using a little helpful acronym, and it's LIATE, and so it stands for log inverse algebraic trig and exponential. And so basically, the farther you get to exponential, that's going to be the thing that is the integral of something. And a lot of people call it dv, and the other one will be u. So let's just try it out right now. If we have the integral from 0 to the power over 2, cosine, what is something that has its derivative equal to cosine? That's right, it's going to be sine x. Sine x's derivative is equal to cosine. Then we multiply by 2x dx. So this is just another way to write our original problem, or our original integral. Now we can rewrite this using our rule that we learned earlier, our little equation, and it is saying to do multiplying the red. And then whenever you have this thing and it is a integral where you evaluate it, you always want to evaluate it here too. Then you minus, and then remember, the prime jumps over, so then we have the integral of sine x. Oh, forgot to put my endpoints. Sine x, and then we have the derivative of 2x, and the derivative of 2x is going to be equal to 2. We're just going to write that as 2 dx. Okay, let's figure out the left side. So the left side is going to be equal to sine pi over 2 multiplied by 2 times pi over 2 minus sine of 0 times 2 times 0, which is going to be 0. So that whole thing is going to go to 0. And then so we have sine of pi over 2. Sine of pi over 2 is going to be equal to 1. And then 2 times pi over 2 is going to be equal to pi. Right? And then so let's do the right side now. So we have pi minus the integral from 0 to pi over 2. And then we have 2 sine x. Right? You guys see how I moved the constant out of the integral? And then we have dx. And then now, what is the integral of sine x? The integral of sine x is going to be obviously equal to negative cosine x. So we have this, pi minus 2 times, and we have negative cosine of pi over 2 minus negative cosine of 0. Right, and then so we have pi minus, and then 2 times. So, the best way to look at this is we go from inside to out. So, let's write this. And so the 2 minus signs in the middle is going to be equal to a positive sign. So cosine of 0 is going to be what? Cosine of 0 is going to be equal to 1. And cosine of pi over 2 is going to be equal to 0. So this is going to be equal to 0 plus 1. And so this is going to be pi minus 2 times 1, which is equal to pi minus 2. That is the answer. Okay, let's jump into another problem. Let's do a harder problem. And so this one will require a small little algebra trick at the end. It's not too hard, but it showcases how a lot of students will have to endure this integration by parts method sometimes. Sometimes it's a little repetitive, And so let's just jump into it. We have the integral of e to the x multiplied by cosine x. Okay. And this is just an antiderivative, not an integral technically. And so with the integral of e to the x times cosine x. So what is going to be our thing that is the prime? Sorry, let me rephrase that. What in our integral is a derivative of something, anything? And so we know sine x, but let's use this little Liet acronym. And e to the x is an exponential, and it's all the way to the right. So we're gonna rewrite this as e to the x prime cosine x dx. All right. So now we can rewrite this, right? We take the reds, multiply them together, e to the x cosine x, and we minus the integral of, and then the prime shifts over, so then we have e to the x times cosine x prime dx. And this is going to be rewritten as e to the x cosine x minus integral of e to the x. And then what is the derivative of cosine? It's going to be equal to negative sine dx, right? And what you know is that the negative is a constant, so we move it out. I'm going to move the negative sign out. So we're going to have e to the x cosine x plus integral of e to the x sine x dx. Okay. It looks like we got nowhere because we don't know how to do this integral. It would be a lot easier if we knew how to do it. Here's where you can use integration by parts multiple times. So if I say, this is our answer, right? This is our entire answer. But if I say e to the x cosine x plus h, or I don't know, whatever letter you want, let's say w, big red W. That's going to be our answer. Now let's find w, right? Let's say w will be equal to the integral of e to the x sine x dx. So now let's find w. I'll do it in yellow. I'll do it in blue, actually. So we have the e to the x times sine x dx, right? Yeah. Let's use integration by parts. So obviously we have e to the x as our thing that we want to re-represent. So we're going to say that it's the prime sine x dx, and we rewrite it as e to the x times sine x minus the integral of e to the x. Shift the prime over, and then sine x prime is going to be equal to cosine dx, right? So this is actually equal to w. But do you notice anything? What was our original problem? E is the integral of e to the x times cosine x. What do we see there? We have e to the x times cosine x dx in w. So we can rewrite this whole thing. Actually, I'm going to rewrite it again. E to the x times cosine x dx is equal to, and then let's say we have e to the x cosine x, e to the x cosine x plus w, and then so now we know it's equal to, I'm just rewriting it again, e to the x cosine x plus, and what is w? Well, w is equal to this whole thing. So we're going to rewrite it. We're going to write e to the x sine x minus the integral of e to the x cosine x dx. Okay, now we have this really fancy algebra trick. It's actually not fancy at all. But we just go like this. We notice this term and this term are the same on both sides. And so now we say plus this integral plus this integral. And so now we have gathered all these terms on the same side. So we can just say 2 times e to the x cosine x dx. That integral is going to be equal to e to the x cosine x plus e to the x sine x, right? And if we're actually trying to find the integral, well, we have to divide this by 2. So now we say the integral of e to the x cosine x dx is going to be equal to 1/2 times e to the x cosine x plus e to the x sine x. Yeah, plus c. It doesn't matter actually if you can do this. Wait, you can do plus c here, or you can do 1/2 times e to the x cosine x plus e to the x sine x. Close the bracket plus c, because c is just a random constant, so 1/2 times c is going to be still a constant, right? Yeah. So yeah, this is the answer. These are the same answer. So I hope I taught you a little bit about integration by parts. And I know this is in preparation for the AP Calculus exam. So make sure you know how to do integration by parts. It's a fairly common integration method, I think. And it proves quite useful in many integrals that you'll see with multiple terms. Okay. Thank you very much for watching.